So we are asked, what is the difference between a reaction intermediate and a transition state? Suppose we are going to plot no, potential energy. Okay. Potential energy versus the reaction progress or reaction coordinate and energy PE. And we have our starting material here, and then it transcends, okay, there and there. So as we can see, the reactant has higher energy than the product. Okay, reactant and the product. So this is an exothermic reaction. Okay. Now, the difference, okay, or the molecule that has reached its highest potential energy is the transition state. Here we have the energy of activation. So if it's from reactant to the transition state, that it is the forward, and here transition to the product, that is reverse, e reverse. Okay, e. So this is our transition state. It is short lived. It is short lived because it's because it will proceed to a product. So that's why it's short lived. It is short lived. Okay, I'll write that one. Okay, it is short lived, and also it occurs in between the reactant and the product. Okay, occurs in between R and P. And also it it is something that cannot be isolated. So, okay, if remember in the problem we've solved, we are asked of the transition state. Now, if the we have A, B, and C, the particle A, B, C, and then reacts to D, then forms AB plus CD. Now, in the transition state, it is the molecule there is A, B, and then we have the C and D. Okay. In the transition state, it is where the bond breaking and bond forming form. Bond breaking and forming occur. So imagine if you are hopping, you start from the ground, and then you transcended up to the air. That the moment the moment when you are going to go down, but still you are in the air, and before you go down, that is the transition state. There's a transition state from going up to going down. So your transition state is the time when you were up on the air. That is your transition state before you go down. That's just the same to a reaction. The reactants hop or the reactants hop and tries to exceed and surpass the activation energy here in order to proceed a product. So the time it was on its highest energy back to a slower energy, that is the transition state. And in a transition state, it cannot be isolated. It exists only a vibration. Okay, it's here, as you can see here. That's why it's dot dot dot, and it is the band breaking and band forming occur because it's not the total bonding that occurs, but only partial bonding and partial breaking that happens there because it only exists as a vibration, exists as only vibration. Now, for a first step or for a single step reaction, we cannot identify an intermediate reaction. It to we have to have two or more than reaction mechanism or reaction step. Now, let's have a two-step reaction mechanism. Now let's plot again. When we plot energy versus the reaction progress. Okay, potential energy and then the reaction progress. So we have our starting material, the reactant. Okay, right? The reactant, then it proceeds and it has achieved the highest potential energy, and then it goes down, 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 and then it hops again. All right, and then achieved another highest potential energy for the step 2, and then it goes down. Okay, so we see that one. The this is our starting material, our reactant, and then it transcends to until it achieved its first transition state. In the transition state again, it is where the reactants partially break and partially forms bonds, and then it goes down, 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 and then here it has stopped. It has again transcended to another transition state because it has not reached its product yet. The thing that has reached here is the intermediate reaction. which is the I, and then the intermediate reaction is your initial product for the first step reaction. It's just initial. And then the initial product or the intermediate reaction was used again as a reactant for the second step. Okay, now that's the time we form transition state 2. And then finally, the transition state 2 goes down and then has formed a product. So here, this is our transition state 1 and transition state 2. We cannot catch it, or it's very drastic. Dali ra kay siya, di siya nato makita because it's short-lived. Unlike to the intermediate reaction, we can catch it because it is long-lived than the TS. I is long-lived. Okay, I'll write that one. We have I is long-lived. Long-lived, and we can isolate. Okay, we can isolate it. Just like imagine again if we are hopping, if this is you, the R, if this is you, then you hop and then up, 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 up until you reach to the highest, uh, uh, highest point on the air. That's the time you have reached your transition state. In the case of the the substances, they have reached their highest potential energy, and then you go down, 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 down. So the time that you were on the air, you that's the transition state. We cannot catch it. It's very short lived. Yes, just imagine hopping and then you go up and then down with a just a glance. Then you go down. You cannot catch it. So that's the transition state. And then you go down, down, and because you have a superpower, you go up again without landing on the ground. You go up again. So uh, the time when you go up again, that's the intermediate, and then you go up and then reach again a transition state, and then the time you landed. Yes. So that's the intermediate. We have we have encountered intermediate reaction already. Uh, for those reactions that we had, okay, example AB. So this is a third step mechanism. So AB, then it forms X. So X here is the product, initial product, and then you use it on the as a reactant for the second step. So the X here is our intermediate. It is consumed. It appears as a product and then it is consumed as a reactant. So that's intermediate. So it is long-lived because we can catch it. That's why it is included in our reaction. Intermediate is included in our reaction. However, the transition state, it's very short-lived, so that's why we cannot, by just looking at this equation, we cannot look at the transition state because we cannot document or we cannot catch it because it's very fast or it's short-lived. Okay. Just just remember that the transition state is the bond breaking and bond forming form. That's the time that we can determine the transition state. Okay, so I'll write the difference. So an intermediate differs from a transition state in that intermediate has a discrete lifetime. It is long lived, be it in a few nanoseconds or many days. Whereas the transition state lasts for just one band vibration cycle and we cannot touch it. So, okay, so that's the answer. Now, if you have answered, it cannot be isolated, it's the bind and breaking forming occur. Okay, so if it's okay if it's not, uh, you have not answered it word for word, just like this. As long as you get the point, then give yourself a point. Okay. So imagine that. Just remember that the TS is the the one in the up. Okay, upper the TS, while the lower is the on the down.